Okay, so here's a simultaneous equations question that you guys asked me to go through. It says find the solution x, y, z for, and it gives us an equation here. So it's funny because it has x, y, and z here with a constant and then an equals. And then an x, y, and z and a constant equals x, y, and z and a constant. Oops. Okay, so, and then an equals, and then it says 0. That means that all this over here is equal to 0. All this in here is equal to 0, and all this here is equal to 0. Okay, so they're all equal to 0. So that is 3 equations. Okay, I have 3 different expressions that are all equal to 0. So I can write them out all equal to 0. Okay, now I can start my simultaneous equations stuff that I'm used to. If you're more used to having the constant on the other side of the equals, you can absolutely rearrange these before we start. Okay, so if you want to, you can rewrite them as 6x plus 4y minus 2z is equal to 5. 3x minus 2y plus 4z is equal to minus 10. And 5x minus 2y plus 6z is equal to minus 13. Now, if you think that that's what caught you off, and now you're looking at it being like, okay, I think I'd know how to do that, then pause the video. Okay, pause the video anytime that you think that you need a minute to understand what I said and to register what I'm talking about. Make sure you go back again and listen again. Or if you think, yeah, I'm actually understanding this and I've explained what to do in the next step and you think, yeah, I think I'd be able to do that, pause it and try it yourself before actually playing it and see me go through it. Okay, so at this stage now, I'm going to decide which variable I'm going to cancel out first. Okay, so on front of the x's, these coefficients all, fair enough with the a and b, it might be easy enough to cancel out the x, but then when I'm using equation C later on, it's not going to be as easy to cancel out the x. Okay, so I'm not going to get rid of the x's. The y's, they actually look easy enough to get cancelled out. Okay, so I'm actually going to decide I'm going to cancel the y's here. Okay, now you could have cancelled something else first and we will still get the same answer no matter what. As long as you do your work correctly, I do my work correctly, we'll still get the same final answer at the end. Okay, so I'm going to do it by trying to cancel out the y's. Okay, so how I do this is I look and see, okay, I need to choose 2 equations where it's going to be easy enough to cancel the y's out. Okay, so I might say equations B and C. Okay, and what I want is, I want to see what do I have to do here in order to get what's in front of the y to be the same number. Okay, now if you were in my junior cert class, you might be comfortable enough to have the same number with the same signs and subtract one line from the other. Okay, if not, some of you said you prefer working with these when the number in front of the y has opposite signs so that you can add the lines. Okay, so if that is the case, that's fine. Choose a line now to multiply by a minus 1. Okay, and multiply across by that so that I will get minus 3x plus 2y minus 4z is equal to 10. And then I won't change the bottom line there. Okay, so now I'm in a situation where I can add the 2 lines. Again, if you're watching this and you're like, okay, I think I know what she'd do next, just pause the video, okay, and see how you'd get on. I'm going to get 2x plus 2z is equal to minus 3. Okay, so now I have an equation with just 2 variables in it. Okay, I'm going to leave that there and I'm going to do this same process again from when I took 2 equations out. I'm going to do that same process again with another 2 of these. Okay, so I've already done B with C, so now I have to do A with either B or C. Okay, it's up to you which. So I will just use A and B together. Okay, so it might look different if you've used different equations the whole way along, but in the end, your final answer will be the same. Okay, so for A, so I'm going to rewrite my equations out. 6x plus 4y minus 2z is 5. And then B, 3x minus 2y plus 4z is minus 10. Okay, so here it looks like it'd be easy to cancel a few different letters, but remember we have to cancel the y because what we're looking for is an equation with just x and z. Okay, because over here we have just x and z, so we want a second equation with just x and z. Okay, so it has to be the y's that we cancel. Okay, so I'm going to multiply that bottom equation by 2. Okay, so my equation B is going to be multiplied by 2. My equation A is not changing, but I still write it down on the next line. Okay, and then we're going to have 6x minus 4y plus 8z is equal to minus 20. Okay, so because they have different signs on front of the y's, we are going to add the two lines together so that we get 12x plus 6z is equal to minus 15. Okay, so I have one equation here with two unknowns and I have a second equation here with the same two unknowns. So now we're in a situation where it is junior cert simultaneous equations. Okay, that is what I have here. I have an equation. I'm going to label these equations. Okay, I'll just use this green colour. Okay, I'm going to label them D and E. Okay, when I look at D and E together, okay, this is a situation from junior cert algebra. Okay, 2x plus 2z is equal to minus 3 and 12x plus 6z is equal to minus 15. Okay, if you were given those simultaneous equations in the junior cert, you would be able to solve for both variables. Okay, that is what we are going to do now. We're going to cancel one variable. Okay, so again, just decide which one you think looks easier. I'm going to get rid of the z's here, which means I'm going to multiply the top line by 3. Okay, if I wanted to get rid of the x's, I would have had to multiply the top line by 6. So it just would have been a bigger number that I had to multiply by. And that's the only reason why I'm doing the z's instead. Okay, so I will get 6x. Sorry, now hold on. That's actually not going to give me different signs. So really, if I want them to be different signs, I will multiply by a minus 3 here. And then that way I'll kill two birds with one stone. Okay, so I'll get a minus 6x minus 6z is equal to a plus 9. And then we will get 12x plus 6z is equal to minus 15. Okay, so this is our junior cert algebra stuff. We are going to add the two lines together so that we get that 6x is equal to minus 6. Okay, so divide by 6 then to get x on the side by itself, and we get minus 1. Okay, now we've gotten minus 1. That's not our junior cert stuff finished. Okay, because you know in the junior cert you also sub that back into one of your equations from up here. Okay, so from D or E, use one of those original equations, okay, and sub x back in to get z. So if I use, let's say, my original equation D, okay, so I'm continuing downwards because I want you to see that this column is fully just your junior cert algebra stuff. Okay, so if I use equation D, it's not 12, it's 2x. Okay, so 2x plus 2z is minus 3. So I'm going to have 2, and now they've told me it's minus 1. Now they didn't tell me, we found it, but still. Okay, so minus 1 plus 2z is minus 3. Okay, so that means I have minus 2 plus 2z is minus 3. So we need to get what z is. Okay, so bring your numbers over to the other side, or use SABMIB. Okay, so we need to add 2 to both sides so that we get 2z is minus 1, and then divide both sides by 2 so that we see that z is minus 1/2. half. Okay, so we now have, I'll get my highlighter out so that the examiner can see. Okay, we now have x is 1. Okay, x is 1 and we have z is a half. Okay, now I'm going to go back to one of my original equations. Okay, whichever one looks easiest, and we're going to sub in x and z to get y. Okay, so I might use equation A. Okay, so equation A was 6x plus 4y minus 2z is equal to 5. Okay, so I'm going to sub in, so it's 6 by minus 1. Okay, y is what I'm trying to find. Minus 2 times minus a half is equal to 5. Okay, so remember we simplify both sides before we try and start isolating stuff. Okay, so if we simplify that left hand side there, we'll get minus 6 plus 4y plus 1 is equal to 5. Okay, so that means we have 4y minus 5 is equal to 5. Okay, now let's use SABMIB or get all our numbers on one side and our variable terms on the other. Okay, so we need to add 5 to both sides so that we get 4y is 10. Okay, so y is 10 divided by 4, which is 2.5. Okay, so you can write it as 5 over 2, okay, or 2.5. And that is our answer. Okay, so I want the examiner again to be able to see my y answer clearly, so I'll highlight it.